Hi, this is the first lecture in this section about sensors and how to use various sensors with your ESP32. And the first sensor that I want to show you how to use is actually integrated inside the ESP32, and it's a sensor that allows you to detect magnetic fields. So what I've got here is a magnet that, as I'm putting close or placing close to the sensor, then I'm going to get a reading indicating the presence of the magnet by this sensor. This is a Hall effect sensor, as it's called a Hall effect, and Hall effect is the effect that a magnet has on the sensor. If you want to learn more about the Hall effect sensor, I recommend this Wikipedia article. It explains the physics behind how this particular sensor works. You can also connect an external Hall effect sensor. So we'll look at the map of the pins. So on the ESP32, you've got these two pins dedicated to connecting an external Hall effect sensor. These two pins contain amplifiers that can amplify the weak signal that this sensor produces in order for it to be able to be used and translated by the analog to digital converter inside the ESP32. But in this example, we'll just go with the built-in sensor. So let's have a quick look at the sketch. There's nothing to connect, obviously, since we are going to be using only the internal components. Here is a sketch. There is no external library to use and install, and we'll be using just the code, or we'll be using the functions that come with the Arduino ESP core installation. So here we've got a variable, just an integer that I'll use to store the value that we get from the sensor. Here in the setup method, we'll just initialize the serial monitor at 9600 baud, and then inside the loop we use the Hall read function to get a reading from the integrated Hall sensor and then print it out. So this particular function, you can have a look at it in the source code here in this file, which is one of the files that come with the ESP32 Arduino core. And if you look at it, you see ESP32 HAL ADC.h header file. Somewhere down here, there is the Hall read function, returns an integer. And that's all there is, just read it. So let's try it out. I'll connect the ESP32 to my computer via USB. Try to get the cable to stay put. Okay. And then upload the sketch. And hold onto the boot button to enable the upload mode on the ESP32. Alright, done. Let's bring up the serial monitor. You can see a bunch of numbers coming through. I'm going to take my magnet and just place it over the sensor. So the sensor is around here. So place the magnet on it. You get a different number there. I'm going to put it closer. You can see that the number increases. If I switch the magnet over, get the opposite magnetic field, then the number becomes positive. So the number that you see in the serial monitor depends on the strength of the magnetic field that the magnet produces. Let's try something else. I've got a really powerful magnet that I got out of a hard disk. So this is a magnet here, and it's much stronger than this one here. So let's see what we get out of it. I'm going to place it right over. It's stuck on the ESP32. You can see it's gone up to the 200s. Flip it over. The other side is not as powerful. It's probably because of the metal that is attached to that magnet. So there you go. or USB disabled probably, I manipulated the cable too much. I'm going to unplug it and plug it back on and restart the serial port and try again. A bit more gentle this time. It's a really strong magnet. Alright. There you go. Much larger values now. And because we are printing only a single value, I should also be able to use the serial plotter tool and actually visualize in a graph the intensity of this magnetic field. So use the Wicker magnet again, and you can see how that changes. There you go. Turn it over. Look at positive values. And I'll use a stronger hard disk magnet now. You get much stronger values. There you go. Or much smaller negative values, depending on the orientation. So there you go. That's how you can use your ESP32 and its integrated Hall sensor, Hall effect sensor, to detect and measure magnetic fields.